Now that you have understood how to prepare your graph table with a given function, so all that remains now is to understand our graph sheet. And this is what graphs look like. As you can see, this is what it looks like. You could see that you can see some thick line and thin line. Thick and thin line. So let's now replicate it on the board. So if let's draw a mini graph here. Let's see, this is my graph paper. So once you understand this, to plot your graph will be very easy. So now this is the graph paper. You have thick lines. These are the thick lines. So now within the thick line, the difference between one thick line and the other, you have it as 5 small lines. So we have 1, 2, 3, 4. By linking, we have 1, 2, 3, 4, 5 round. So which means, now within the thick line, you have, in between the thick line, you have 4 lines. But if you count from one end to the other end, you'll be having 5 lines. So that's why we did it as 1, 2, 3, 4, 5. So you must understand that. And for a square box, let me put this like this. For one square, I will tell you why it is square. Square, but because it is the same, it has the same length. Right. So I'm expanding this and bringing this now out. So I'm now having this. So this is one. So let's bring it out. So now we are now having our small line. 1, 2, 3, 4. So which is 1, 2, 3, 4, 5. Now, so this is what we refer to as call it square box. So now one square box, the length of one square box is equal to 1 centimeter. You must know that before you start plotting your graph, that the length of a square box, it is 1 centimeter. So this is why it is called square all round. It is 1 centimeter. So you understand that if the length of the square is 1 centimeter all round. So you must understand that. So if I now put two of these together, if I now have 2 square boxes. So what does it mean? It means that from here to here is 1 centimeter, from here to here is 1 centimeter. So putting the two together now will give you 2 centimeter. You see now, 2 thick lines. That means the 3, 1, 2, 3 will give you 2 centimeter. Please understand this, because it will help you out to pick your answer from the graph. It will help you out to locate any point on the graph. Are you getting me now? So by the time you begin to plot your values on the graph, so you'll be able, it will be easier for you to point it out by understanding all this what I'm explaining. So we have it as 1 from here to here is 1 centimeter. If I now have 2 square boxes together, it will give me what? It will give me 2 centimeter. So if I also have it to this length, so from here down to this place will also give me 2 centimeter. You see now? So which means from here down to here it is 2 centimeter. So from here down to this place it is what? It is 2 centimeter. So you can now use this simple analysis to now do any length. If I want to do 3 centimeter, it will stop here, 3 centimeter from here down to this place. If I want to do 4 centimeter, it will be from here down to this place. So altogether, it will be 4 centimeter. So once you know that, this will help you. You know, you will see that in WAEC, you will be given, you have already been supplied the scale. You know, they will say, use a scales of 2 centimeter to 2 units or to 3 units to any unit. Now, where does the unit come from? The unit is the number of progression, that is what you are having that you need to put on the graph. So let me, for instance, if I'm to represent, let's say 1 centimeter to 2 units. So if this is my scale that was given, so now how do I now replicate? How do I now do that on the graph? 1 centimeter to what? To 1 unit. And I already know that a square bus, the length of a square bus is what? Is 1 centimeter. I don't have issue with that. So what they are saying is that from here down to this place is my 1 centimeter. Now, how do I now progress with the units? So the units, it is a figure you are assigning to each thick line. Now, when I now say, if here is 0, so I need to go by what? 1 centimeter. From here to here is 1 centimeter. So what is the figure should I put here? As the scale says, I should proceed with what? 2 units. That is the interval. So I'll write 2. So the statement here means that 1 centimeter from here to here, 1 centimeter represents 2 units. So if I want to write what is going to be in this place, I will move by, this is another 1 centimeter, this is another 1 centimeter, then I will proceed with another 2 centimeter. If you add plus 2 to this, you have what? Here will be 4. So this is how you can now use that method to put your unit on the graph. You can now produce your scale on the graph. Are you getting it now? So by knowing that the square line of the length of a square bus is what? Is 1 centimeter. So I can also proceed vertically. If let's say I was giving, let's say we have 2 centimeter to 5 units. To 5 units on vertical axis. So all I need to do, so here is my vertical axis, here is the horizontal axis. I'm still coming to that. So now to put this statement on the graph, let's say this is my origin, this point. If here is 0, if this place is 0, and I already know that the length of a square bus from here down to this place is 1 centimeter, but I need 2 centimeter, so I need to move ahead with another 1 centimeter. So from here to here is 1 centimeter. So I will now move again from here down to this place by another 1 centimeter. So which means from here now to this place is 2 centimeter. That is what I'm looking for. But I should proceed by what? By 5 units. So I should go, that is my interval. So which means if here is 0, once 2 centimeter will give me, I'll put 5 here on the graph. So if I move another 2 centimeter from here down to this place, I move another 5 centimeter. So this one will now become 10 at this level. You will see that from here to here, the difference between this and this is 5, and the difference between this and this is also 5. So if I move another 2 centimeter upward, then I have to write 15. It will now be 15, 20, 25, depending on the highest value you have on your table for y. So that is how to replicate all this. You must know how to do all these things. Now, another thing that I would like to explain is this. Now, let's assume that you've scaled. Okay, let me use let's use this one. You've scaled this on the graph, and you are now looking for 0.5. let's say we are looking for 0.7 on the y-axis. On y-axis. Don't forget that y-axis is the vertical axis. Now, so you've already produced your scale on the graph by 2 centimeters to 5 units, which we have done on this line, on this vertical line. Now, maybe on your table of value, you have to locate 0.7 on the graph, of which probably you are having 0.7 among the values you have on the table. So, and on your graph, there is no 0.7 there. How do you now determine 0.7? That is why we also now need to understand this thin line. In between the square box, you are having 5 thin lines. So from one to the other, you are having 5 thin lines. So which means you also have your thin line in this way. 1, 2, 3, 4. 1, 2, 3, 4. So let's proceed this. So for us to be able to get now we need to look for our 0.7. We are looking for 0.7 on this graph. So how do you determine that? So very simple. Whenever you are at origin, look at your first number, your first unit. Like on this graph now, my first unit is 5. You see that? You write it out. First unit is 5. Let me clean. So let's clean this part. Now, I want to determine 0.7 on this graph. So how do you now know 0.7? So you need to know the length of each small line. Now, for you to know the length of each small line, it depends on your unit, the origin and the first unit. If it is 2 that is here, you write the 2. If it is 10 that is here, you write the 10. So that is what we want to determine now. Now, the first number I'm seeing here now is 5. So we write 5 divided by the number of lines in between. You see now, the number of lines in between. So I think we just need to write the formula for it. Let's write length of thin line is equals to length of thin line is equals to first unit divided by number of thin line. So now this is how you'll be able to know the length. We already know the length of a square box, which is 1 centimeter. So you also need to know the length of this small box for you to determine the 0.7. For us to determine 0.7. So now the first unit I'm seeing on the graph here now, this is 0, the origin is 5. Any number could be the first unit. So I'll write 5 divided by the number of thin lines. I'm having 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm having 10 lines. So this is 10 lines. So that will give me 0.5. Now let's now see if it's correct. So which means each line is 0.5. 0.5. Here too is 0.5. 0.5. 0.5. 0.5. 0.5. 0.5, 0.5, 0.5. So each line, each thin line is 0.5. So 0.5 plus 0.5, that will give you 1 plus 0.5, 1.5, 0.5, that is 2, plus 0.5, 2.5, plus 0.5, that is 3, plus 0.5, that is 3.5, plus 0.5, that is 4, plus 0.5, that will give you 4.5. You now add 0.5 that is here to it. So that will make it 5. You see now, so it means that each small line, each thin line is 0.5. Do you see the logic now? Each thin line is 0.5. So let's take another example. Let's say I'm having 1, 2, 3, 4. Let's say here is 0, here is now 2. Then maybe probably I'm looking for 1.5. I need 1.5. So let's say I'm looking for 1.5 on the x-axis. I'm looking for 1.5 on the x-axis, and this is 0 and 2. So I don't even know where 1 is. Are you getting me now? So how do I now know the length of this this thin line? How do I know the length from here to this place, or from here to this place? The distance between here and here. So how do I do that? Let's follow our formula. That the length of thin line is equal to what? First unit divided by number of thin line. So the first unit I'm seeing here is 2. So I have to write 2 divided by number of thin line. So I need to calculate the number of thin line from this point to the first unit. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You see now, so it becomes divided by 10. That will give us 0.2. So it means that each small line is 0.2. Each small line is 0.2. So let's calculate. It means that from here now, I'm having 0.2, here to 0.2, here 0.2, this place 0.2, I'll have 0.2 here is 0.2, this place to 0.2, this line is 0.2, here is 0.2, then on 2 you have 0.2. So let's now add it up to see if you are going to get 2. Look at it, let's just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 times 2, that is 10 times 0.2, that will give us 2. You see now, so you can say 0.2 plus 0.2, 0.4 plus 0.2, 0.6 plus 0.2, that is 0.8 plus 0.2, that is 1. So our 1 is at this point. This is where we are having 1. You see now, plus 0.2, 1.2 plus 0.2, 1.4 plus 0.2, 1.6 plus 0.2, that's 1.8. You now see 1.8 plus 0.2, that will give you 2 plus 8, 10, you keep 1. 1 plus 0 plus the other one you keep. You see now, that will give you 2. That's how it is being done. So this is how you'll be able to split your graph for you to look for any value you are asked to get or you want to locate on the graph. So you can apply this formula to determine the number of, okay, before, let me do the quick one, final one. Now, if I'm having, let's say I'm having 0 here, I'm also having, let's say 100. Now, how do I now divide this 1, 2, 3, 4, 5? So what will each line stand for me to have 100? So the first unit, if you go by the formula, that is first unit divided by the number of thin line. So the first unit here now is 100. So 100 divided by how many small lines? So I'm having 1, 2, 3, 4, 5. So 5. So that will give me 20. So which means each small line will stand for 20, 20, 20, 20, 20. So 1, 2, 3, 4, 5. 20 times 5, that will give you 100. So you use this method to calculate your value. Okay, that is how you can solve your graph and be able to plot your value on the graph. Now let me quickly take you through how you pick value on the graph. Let's say I have my y-axis, this is y-axis, and this is horizontal axis. Then plotting your graph, let's say for instance now, we are plotting a graph of a quadratic functions. So that is in the form of y equals to as squared plus bs plus c. So let's say you are plotting this graph. You've plotted this graph, and it's giving you if the value is a, b, and c, they are constants. They are constant. It means that it could be any value. Now, if a is greater than 0, your graph will give you U shape. I've explained this in the slide, so I'm just doing it so that you understand what I explained in the slides. So, and if this value here is less than 0, it will give you an inverted U shape. And don't forget, these shapes, they are called these two shapes, this and this, is what we call parabola. And why is it parabola? Because you have a line of symmetry that divides this line into two equal parts. If it is like this, you have a symmetry line. This is a parabola that has a symmetry line. If I measure from any level, for instance from here to here, we give you the same value from here to here. So that is why it is called parabola. Now, and this point here is what we call turning point. We call turning point. So it is turning point. You see now. So when they are asking you, and if you are not asked, okay, so let me now replicate this on this graph here, so that you will be able to know what we are seeing. So let's say I prepare my table for this function, and let's say it is this graph now, a is greater than 0, which is going to give me U shape. Let's say I now have this value. So, okay, let's say I proceeded with 2, 4, 6, and I also have -2, -4, -6. Let's say I have 1, I have 2, -1, -2, I have 1, 2, 3, 4. So let's say this is the graph I came about from the table I prepared from here. Now, and they're not asking you what is the root of this equation, of this function. Root of this function. The root of this function, it is where the graph of this function called x-axis. This is x-axis. So you read this value, you also read this value, and you see that the graph does not fall on any of this number. So you now use our initial what I've explained earlier to determine this value. You know, in between these 2 and 3 now, you're having 5 small lines. So what will each small line become? So you count 1, 2, 3, 4, 5. So and there's 1 here. So which means it will be 1, that is the unit, the first unit, divided by what? The number of lines, which is 5. And that will give us 0.2. So which means by the time if you are having 2 lines, a thin line before this place, which means you add 0.2 plus 0.2, 0.4 plus 2, that will give you 2.4. So you'll be able to read this value and be able to read this value. So this is where you read the root of the equation from. You see now? So that is how you read. Let's say you are given another linear equation of this form, y equals to ms plus k. So with this, because there's no square, it will give you a straight line. Then from your table, you pick the value of x. Just pick 3 values. Let's say we are having a range of -3 less than or equals to s less than or equals to 2. So the value of x now we take from -3, -2, -1 is 0, 1, 2, 3, 2. Now, all you need to do is to pick the first value, pick the center value, and then pick the last value. Just pick 3 values. So from here now, you see when s is equals to -3. Don't forget, this one will have value, s will have value, k will also have value. You have a value for y. You will now come here. When x is minus 3, you will get the value from here. You already know the value for this. This is minus 3. You know the value, the total. You plot it here. So I will still show you. I'm just telling you how to pick your answer. So let's say at the end of the day, we now have something like this. And don't forget that whenever you are plotting your graph, you have to label everything, all the function you are giving. Like on this one now, this is the function we've drawn. You write on the line y equals to as squared minus plus bs plus c. That is the function. For this straight line, we have y equals to ms plus k. Now you have to put it there. Now they now ask you to look for the solution of this graph. So for you to look for the solution or root of this graph, solution. So you now come to your graph where the straight line meets the initial graph. So this is where they intersect. Here it intersects. Now if you look at the function, it's a function of x. Look at this function, y is only function of x. So that is why you trace your answer to horizontal line on the x-axis. So you draw the vertical line. You don't need even to draw. You can draw it or you leave it. You will see either thick line or thin line. Just follow it down. Then you pick your answer from here. You also come here. You follow the thin or thick line down. You pick your answer from here. So this will be the solution to this other function. So this is how you begin to answer all the questions on the table, on the graph. So you pick your solution from the graph. So now we are now going to be solving it on the graph. We plot our value. The value you've prepared now, we now need to now plot it on this graph. So I've explained everything you need to know on this graph. So we move to plotting our